Hi guys, I'll be podcasting the solutions to the Unit 8 practice test on stoichiometry. My name is Ramsey, and I'm a member of Block 1 and Block 3. How many things are in a dozen? 12 things. How many things are in 2 dozen? 2 times 12 things. How many things are in a half a dozen? 1/2 times 12 things. What kinds of things do we count using a dozen? Some of those things are eggs and donuts and flowers. Why do we count the above things using dozens? 12 eggs is a good amount of eggs. If I went to the store and bought 1 egg, wouldn't be enough. 1 egg, not good. If I bought 100 eggs, that's too many. But 12 eggs, that's good. How many things are in a mole? Well, a mole is just a number of things. And there are 6.02 times 10 to the 23rd things in 1 mole. In 2 moles, 2 times 6.02 times 10 to the 23rd. In a half a mole, 1/2 times 6.02 times 10 to the 23rd. What kinds of things do we count using moles? Well, the major thing is just atoms. We also could say compounds. Another word for compound is molecules. Okay. Why do we count atoms, compounds, or molecules using moles? Okay. Atoms, compounds, molecules are so small that we have to use a large number of them. And that large number that we're choosing to use is a mole, or some fraction of a mole. Moving on to the next problem here. Part 2, molar mass calculations. Platinum, which is PT. The molar mass of platinum is on the periodic table. It's got 78 protons. It's 195 grams in every mole. And the percent composition in this case is going to be 195 divided by 195 times 100, which is 100%. Bromine. On the periodic table, bromine is about 80. So it's going to be 80 times 2, which is going to be 160 grams per mole. And in this case, it's also all bromine. 160 times 160 times 100 equals 100% bromine. Butane. Okay, but means 4. That would be C4, and remember it's CN H2N plus 2. So that would be H10. Well, carbon, there's 4 of them times 12, so that's 48. Hydrogen, we have 10 of them from that 10 right there, times 1, that's 10. 58 grams per mole is the molar mass of butane. For the percent carbon and the percent hydrogen, we take the total amount from the carbon and divide it by 58. Hi, Mr. Phil. And we get our answer.
My name's going to be on YouTube.
Yep, you're famous. And multiply by 100, and I'm too lazy to go get the calculator sitting at my desk, so I will not go get it. 10 divided by 58 times 100 will be the percent composition of hydrogen. What are you looking for?
The scissors?
Scissors?
Yeah.
There's not the box. Are they in there? Okay. For calcium phosphate, we have 3 calciums, and that's going to be multiplied by 40, giving us 120 for the calciums. We have 2 for the phosphorus, and that's going to be 31, giving us 62. And for the oxygens, we have 8 multiplied by 16. So that's going to be what's 8 times 6?
48.
That's going to be 108. We're going to add all these up, and we should get, I believe, 310 grams per mole. For the percent calcium, we're going to take 120 divided by 310, multiply that by 100. For the percent phosphorus, we'll take 62 divided by 310, multiply it by 100. And for the percent oxygen, we will take 108 divided by 310, multiply it by 100. If you guys didn't understand any of these, just slow down the video and watch this part again. Part 3, mole recipes. So let's balance the equation first. I have 2 hydrogens on the left and 3 on the right, so we're going to do the 3-2 switch. So make Magic Johnson, Michael Jordan. Put the 1 in the front there, so you should have 3, 1, and 2. So the mole recipe simply would be that 3 moles of H2 mixed with 1 mole of N2 produce whatever you would like, 2 moles of H3N. Great job. I told you guys not to worry about this one, so we're not going to worry about this one. Going on to the stoichiometry calculations. Now, I might have to stop this early and start another YouTube clip, depending on if I have enough time. So when I balance this, I got 2, 2, 1. And Cl2 is one of the chemicals involved, and Na is the other chemical involved. I'm going to underline those up here. The molar mass of Cl2 is 70 grams per every mole Cl2. The mole ratio is 1 mole Cl2 per every 2 moles Na. Okay, that 1 came from there, and that 2 came from there. And 23 grams of Na per every 1 mole Na. Do my crisscross. I start off with 0.003 moles of Na. And I want moles of Cl2. I do not see the word gram, so I'm not going to need a molar mass calculation. What I got on the bottom is Na. What I want on the top is Cl2. That cancels, and I have 0.0015 moles of Cl2 in my final answer. For this one, the chemicals in this recipe are going to be NaCl and Cl2. NaCl's molar mass is 58 grams per every 1 mole of NaCl, and the mole ratio between NaCl is 2 moles NaCl per every 1 mole Cl2. And the molar mass of Cl2 from the last problem we saw up there was 70 grams per every 1 mole Cl2. I'm starting with 2.3 moles Cl2, and what I want is grams NaCl. So I always use the mole ratio bubble, or step, I'm sorry, and in this case I have to use a molar mass, and it's going to be the NaCl because that's what I'm looking for here. Go through and do this. 1 mole of Cl2 per every 2 moles NaCl. Cl2's cancel. Finish that. Moles are going to be on the bottom here, so for every 1 mole of NaCl, 58 grams NaCl. So in this case, I'm going to multiply 2.3 by 2. That's going to be 4.6. I'm going to multiply that by 58. So 2.3 times 2 times 58 grams of NaCl. I do not have a calculator on me, so that's what you're going to do to get your final answer. I'm going to finish up the last problem on the next clip. Take care.